Hi, I'm Mark Tucker,
And I'm Alan Furstenberg, and we are Two Voice Devs.
Two Voice Devs. Hello,
Hey,
Alan.
Mark, good to see you again.
Yeah, thanks. You too. How are you?
Getting by. It's been busy, but finally wrapping up one project and moving on to another one, and that always feels good.
Yeah. Still a little give and take, huh?
It's always give and take, isn't it?
Yeah.
That's kind of the nature of what we do. How are things there?
Things are going fine. Definitely busy. Project wise. There's lots going on, which is good. It's a nice way to start the year off. But yeah, just exciting things going on. Hopefully sometime I'll be able to talk about it. But right now I'm heads down, getting things done.
Getting things done is always the good part. So yeah, I know what you mean about getting things done.
I've been working on some things and just, once again, thinking about, actually HTTP, because, in the end, well, I guess in two different cases, right? When we're working with Alexa Skills and Google Actions, then the endpoint or the webhook, however you want to call it, that is handling, the application logic for the skill or action is based off of HTTP and also kind of REST the APIs that we call inside of our voice app code is most times is REST, or a lot of times.
And that's built on top of HTTP as well.
Which is also built on top of HTTP. And I think we had a brief conversation that there was an intern that I had, probably a year ago. Well, actually probably more like a year and a half ago. But anyway, that they had gone through school, but they weren't taught the basics of like HTTP. And it's something just, if you don't know it, then things seem a little bit more mysterious. Not that we're going to go into tons of depth, but it's important to know that when you do HTTP, it's a request and a response. So you send something to an address and a port, so a certain machine and a certain port takes that, and then part of the protocol is that it comes back with a response.
And one of the great things about HTTP, and it's kind of why it really was the one that grabbed hold over previous internet protocols, is that it is just that simple. It's a fairly simple and straightforward request and a fairly simple and straightforward response. And over the years, the community as a whole, have added layers on top of it and defined specific things about it.
Right.
But fundamentally, the HTTP protocol that most of us are using today, at its core, is the exact same protocol that I first used back in 95, 94.
Yeah, it's crazy. So like if you think about it, back then when you were, back when I first started doing web programming, then everything was served up on the server. Everything was done server side. So you would say, web server, give me this page at this address.
This address. Yeah.
And it came back with HTML, and that's, so you had the URL, which was a request with no payload, with a response that was a payload, right? That had HTML coming back as on the HTTP side. So
right. And what was great also at the time was that HTTP allowed for things like saying, I would prefer that this be in English, but you could also send it to me in French or German. Or I would prefer that the response be an HTML page, but if you only have it in PDF or text, send me those instead. Yeah. And that's been a part of the protocol for a long time. And it's been extended since. And things like REST take advantage of that feature, which have been part of it for a very long time.
Yeah, so, and then like I was gonna say, the next thing that we saw on were web pages where then you're your HTML page would have JavaScript that would do a
Well,
XML HTTP call, right?
I would say even before then, what we had was that we had HTML pages that had forms in them. And these forms could now send payload to the server.
That's true.
So previously, the first types of requests would only be get this page, get this resource.
Yeah.
And once forms were introduced, we had this notion of post this information to the server.
Yep.
And you would get something back in response as well. And those notions, the get operation and the post operation still exist today. They've been expanded a little bit. We now have other things that go on with them. But those were some of the foundational issues. And then as we started getting JavaScript, we saw the need, as you said, of JavaScript to be making some of these calls itself.
Yep.
And that's where we got the, I always mess up the name, XML HTTP request.
I think it was.
Did I get that right? Yeah.
Yeah.
Where the JavaScript was making the call and getting the response back. And then we wanted to start doing things like, well, we want more complicated data structures and we want to handle these more efficiently. And that's where you saw JavaScript starting to really blossom and really do some advanced work.
So what would happen if I typed in a URL to a page that didn't exist? What would happen on the browser?
No, that's a great question. And one of the we'd get the infamous 404.
Yeah, 404 not found.
Right. So what does that mean?
So what also built into this HTTP is this idea of you always get back a response. It could have a payload or not, but it always has some sort of a status code. And there's different numbered ranges. So like if it's a status code 200 or something in the 200 range, those are varying different success scenarios. And if it's in the 300 range, maybe when you originally had the web page, you moved its location, but you still wanted it to be accessed by the old URL. So then you could actually return back something in the 300 range saying, oh, this page is moved and I'm going to redirect you over to this page. Or in the 400 and 500 range is like 400 is there's some sort of an error and it's typically associated with the client or with, the format's not right or something. There's some problem with your request. Whereas something in the 500 error range is that there's some sort of, bigger server error that, the server's just not processing things or, maybe it's a database connectivity error or something like that.
Now, it's also important, though, to note that some of these response codes are, we talk about 400 being a negative code. And it's not always so bad because things like authentication also come back as part of a 400 code. So not all of these are necessarily fatal errors, but they're saying, I can't quite do that right now.
Yeah, and the client can respond to that and like, okay, I'm going to retry this, or I need to.
I'll prompt my user for the login and send that information to you, or there are various things that you can do. Whereas something like the 500 error codes are fatal.
Yeah. So typically when you're I guess fast forward now when we're using this same technology for making API calls, then that still applies. You can make a request for information. Maybe you want a list of something back in a JSON array, and a 200 would indicate, yeah, I successfully got this list back. Whereas something else would indicate that there was some sort of an error, and your code could respond to those status codes and behave appropriately.
Mm-hmm. And again, I think one of the beauties is that this notion of a response code, it's actually deeply historic in internet protocols. You'll find the same concept in FTP protocols. You'll find it in older protocols as well. But on HTTP, they've been there pretty much since the beginning, and they've been, with minor variants, pretty unchanged for a long time. So they're very well understood and very well documented. And there also aren't too many of them. I mean, on the FTP side, there are tons and tons of codes.
Mhm.
On the website, there aren't nearly so many, which is in some ways kind of refreshing.
Well, and a lot of times, even some of the utilities or libraries like Axios or others that you would use to make these API calls through REST, which we'll talk about here in just a minute, give you some sort of indication if it's a successful or not. And they can even just typically look at, is the range of errors in the 200s or 300s, and that would be one type of response versus you don't have to handle every single one of those codes. You can handle them in ranges, or you can also handle some of them specifically if you needed to do that.
Or in some cases, you can let the library do so. One of the good things is that a number of the 300 series codes, since they're redirect codes, the library can automatically handle for you. If this API is moved to this other location, I'll just call that with the same information in some cases. There are nuances there, but broadly speaking, you can sometimes get away with doing that.
Yeah. So what does REST add on top of, or do for HTTP? Because in the end, it's still HTTP, but what does REST do for us?
I think what REST, and this is the interesting thing I always found about REST, is that a lot of people talk about REST and mean slightly different things, because there's no such thing as the REST protocol.
Yep.
There's, it's a broad set of, it kind of is now a broad set of guidelines that say resources are located at paths, URL paths. And when we're referencing them, we can use HTTP request types, GET, POST, PUT, some others, and they carry with it some meaning. So GET, for example, usually means you're getting a resource and you're assuming that nothing is going to change on the server. It's what we refer to as idempotent, a nice fancy term that says nothing changes. Yeah. If I get a resource and I get a resource again in a minute, it's the same resource. Whereas things like post or patch carry with it the semantic that I'm going to be changing something about the resource at that location that I'm specifying.
Yeah, and what REST does is it has some guidelines, and as far as like how do you name the URLs? Like if you're dealing with products, then you'll have some base URL and then /products. And if you do a get to /products, then you're going to get a list of all your products. Now, maybe you have query strings or you have headers or something that could,
extend that,
or like give you some specific like filtering or other things. But the idea is basically, if I do a get to /products, then I get everything. If I do a get to /products/1, then I'm going to get the detailed information for product one, as opposed to a list of all the products.
Right. And it might further say, if you call get products and you provide a query string of search equals something, then it does a search against the products, as opposed to doing a get /users with a query string of search. That would be a search against users. And again, these aren't rules. These are just guidelines, and they're best practices.
Right.
And developers, going from one to another, you learn to start to read the documentation well to understand what the best practices are telling you.
Yeah, and typically in a get, then you don't have any request payload. It's just all what you're going to do on the as part of the URL and the query string after that. Now, if you wanted to create a product, then it might be, you're hitting the products endpoint and you're doing a post method type of request, and then you've got a payload request payload that includes all the information for the product. Now, is it something where you're specifying what the ID, the uniquely unique ID is going to be, or is it something where you pass that information and you post it, and part of the response then is going to be the ID of the item that you just created? I guess also in that same vein, you could use a post for an update, or you could use a patch or a put for an update, right?
Right. Usually, though, the best practice is the guidelines kind of suggest that you'll use post when you're submitting something new, or put when you're using something new, and patch is usually reserved for editing something that already exists. Mm-hmm. Again, broad guidelines. And these days also, when we talk about the contents, we're talking about JSON in the body of what we're sending. But again, that varies, and that's certainly varied over time. When REST first started really getting a toehold, that payload was almost always XML, and you'd be getting XML back.
Right.
One of the neat things about a lot of REST endpoints is that, in fact, you can specify what format you're sending it in and what format you're expecting it back by changing the content type header and the accepted, I think it's accepted. Yes, it's accepted header. So you could say, this content is in JSON, or you can say, I will accept HTML. And what a lot of sites will do is that if they see that you're accepting HTML, they'll say, oh, you're accessing this directly through a browser. I'll give you the documentation for this endpoint instead of the content. Or maybe it will give you a web page that you can dynamically do something with the content. So, it will give you an HTML formatted list of your products. And you can click on one and browse through it using a browser. And your automated system will say, I'm accepting JSON, and it will get back the JSON because that's an automated system.
Yeah, so you could have one endpoint, like, so if I'm making the API, I could have my endpoint where I'm saying, get me a list of products. I can check what that content type is that the client wants the response to come back in, and I can say, oh, I do my stuff and I get back my response. Before I send it back to the client, I can say, oh, what format do they want it in? Oh, JSON. Okay, I'm just going to ahead and pass off JSON. Oh, XML, I'm going to format it in XML. I'm going to send it back. And so then multiple developers that are using your API can determine, oh, my system is going to be easier if I handle it as XML or
exactly
or JSON. But
so again, these are nice broad concepts when it comes to REST. Now, one of the things we mentioned, we kind of glossed over a little bit, is we talked about how our webhooks are essentially using HTML to communicate with the assistants. And it's not really true, because there's another layer in there, which kind of in some ways complicates things and in some ways makes things better. And that's, we're not really using HTTP, we're using HTTPS.
S for security.
S for security, and hey, there's nothing to knock about it. But what that basically does is it builds on top of HTTP, so it's really underneath. It's the same protocol, but instead of using it on a normal TCP line, which is open to anybody who has access to your packets, it uses SSL. Or TLS, that's a secure socket layer or transport layer security, to encrypt the communication. So all it's doing though is encrypting an HTTP request and the reply. So it's the same protocol underneath. It's just now you're exchanging it over an encrypted line, which is good. Encryption's good.
So the endpoints or the webhooks, however you want to call them, that for both Alexa and for Google Assistant, in the end, really are just an HTTP post endpoint, well, an HTTPS endpoint that accepts post body that's in the format of the body request body is JSON and the response comes back as JSON. So you could code just a web server that has one endpoint that accepts a post JSON body and returns a JSON response body, and that's really all you have to do. But and any of the libraries or frameworks that are out there for building these skills are just making it easier to grab the request and not necessarily have to deal with the raw JSON, but like surface different values and helper methods and properties and whatnot, so that that you can handle the input, map it to some sort of a handler, deal with the logic, make your own API call, get the response back, format that, and then it turns that into the JSON message format and then sends that back.
Yep. And we've talked about libraries a couple of times in the past. There are plenty out there. There's Jovo, Multivocal. Google's got several libraries for theirs. Alexa Skill Kit for theirs. So plenty of libraries that are out there. But you don't need to do any of them. If you really wanted, you can handle the HTTPS and the JSON yourself.
Which means really, if I wanted to learn Node, and that's where a lot of the early examples were in. But you could code for these voice assistants in any language that you want that can handle that. So
right. I think that's one of the great things in general about HTTP is that it's so ubiquitous that almost every language these days has plenty of libraries to help you on with that front as well. Right. JSON is ubiquitous enough that there are lots of libraries around in any language that you want to work with. So, use what is most comfortable to you or what you want to work with.
Yeah, no, exactly. So if, I know that there are libraries for like .NET. If you're doing C# stuff and want to do Alexa skill, you can do that. There is for Python. I'm sure that there is for Go or for other languages that you want to use. Not that we're not really getting into I'm hosting this on a server versus serverless and like Lambda functions and Google Cloud functions. But in the end,
we'll deal with that another day. In the end, it's HTTP.
Exactly. So it's just where are you going to host it or how are you going to host it? But in the end, it's just some endpoint that accepts HTTP post and deals with JSON.
One of the things that we talked about a couple of weeks back are the really obscure cross-origin resource sharing headers. CORS. And that's a relatively recent addition to HTTP. And it's mostly to deal with browsers who want to be able to do things like contact APIs that are running on servers that are different than the page that you loaded. And it started because it raises questions of, if I'm running a web page and I'm running JavaScript in a web page, and I try to get something from somewhere else, how do I trust that somewhere else? And almost as importantly, how does that somewhere else trust me? And that's what CORS is set up to address. So it's basically a set of rules, which we are not going to go into tonight, that say, if I am a web server, here is what I am allowing. And if I'm a client, here's what I'm allowing the web server to do.
Yeah, but in the end, it comes down to the same methods. Is it a get or a post or a put or a delete or a,
Yep. And what content type am I looking for? And what content type is returning? And what servers do I trust? And so all very, very much in the flavor of what has been with HTTP all along, just adding additional security as we saw it being necessary in the browser.
Yeah. So as we wrap up, what are some of the disadvantages of REST? I know that there's some newer things that are coming out, like GraphQL or other ways. So like why did those come out? What was the need that it was trying to fix?
That's actually a good question. I'm not entirely sure. The feeling I've always gotten is that in a lot of ways, REST is not well-defined enough. And there are people that want more clear definitions. REST is very much here's a broad guideline of what you should do, while others say, here is the exact protocol, and here's how you know exactly what is on the other end, and here's exactly how you can find that out. Here's how you can find out the schema, and here's how you can find, here's how you can do all of these things. And REST kind of says, yeah, you might want to think about doing that.
One of the things that I've seen, or at least on that, kind of maybe a different perspective, is that REST divides things up very chatty. So it's like, if you think about products, I'm dealing with products, I'm dealing with people, I'm dealing with whatever your thing is. So you've got the thing that you're dealing with, and then you've got all the different, like what you would do to serve up CRUD, create, retrieve, update, delete, right? So those kind of map to some of the different HTTP methods. But in some cases, it makes it kind of chatty. So like if I need to do something with a product and all the orders that product are part of, then what seems to happen a lot, depending on who's designing the API, is that you have to make a call to get your recent orders. And so maybe you get back a response that has your recent orders, but then it's got a list of product IDs. So then you have to make a call to get each of those product IDs. And if you do it, too strictly, then now that's like a whole bunch of API calls that you have to make to get back the information that you want on your client side, because of those, joining the information together. So if you make that REST call too chatty, then there's a whole bunch of calls that you have to make to do that. Whereas, and also it's kind of rigid. You're like, this endpoint is going to return back a list, and there's not, if you don't build into the API, then it's kind of limited on what it can return back, like which fields. Like maybe in some cases you're on a field and you're just listing things, and all you really need is the ID and the name. But maybe on some other place you need all of the details, or you need part of the details. And so with REST, it's hard to kind of that object that you return back, determine on what properties are going to be part of that object to return back. Mm-hmm. So with something like GraphQL, then it gives you some flexibility. You're more defining a query, and you can, if developer one is using it in a certain context and they want this information back to show on the screen, and developer two is using it but in a different way, then they might want completely different data to come back from the same API and the same endpoint. And so with GraphQL and things like that, you can define, like, this is the information that I want, and I want you to join it to this thing, and these are the properties that I want you to come back with. So you get more flexibility as a developer to get back just the information that you need. If you're working with something that has a whole bunch of properties, but you don't always need all that many in the context that you're using, you're just wasting space having it go back and forth.
And most importantly, you're wasting time, especially when we're talking about voice apps. We need to respond as quickly as possible. And, if you're making 20 queries to get the information you need for just one response, that's going to take way too long.
Yeah, and I've hit that. That's one of the biggest headaches with doing projects on as an agency, because you walk into a situation, they've got some existing APIs, and you're like, sure, we can add voice, to this, and then you get into the APIs, and you're like, oh man, now I have to make 10 calls. When the voice app first starts up, and you start worrying about how that
and the
experience is going to be.
One of the interesting bits to me is that we actually see this as well in the evolution of HTTP as well. Is that originally, when it was mostly built around browsers, what they were focusing on doing was establishing a connection. You get a request, send a response, close the connection, and you're done. And what they started seeing over time is, no, really what's happening is you're connecting to a server, and you're getting one piece of information. You're getting an HTML page, and it's going to make you load 20 graphics. So now you need to make 20 more calls to get all the graphics. So over time, they optimized HTTP a little bit for that. And now we're seeing even more optimizations where we're saying we can do some of these round trips. So we can now start pre-caching or start getting responses back start getting the graphics back even before we've gotten the entire page.
Yeah.
Because we know I'm going to send you all of this at once, or we're going to need to send you content bundles. So we're sending a page and all its graphics at the same time. And then starting to look at other optimizations based on how are we making those calls? What are the things that we tend to do when communicating between a client and a server?
Yeah.
And HTTP is evolving to help handle with those scenarios.
Yeah, so it's just fascinating to me because things have changed a lot. The types of applications that before it was like a website with 20 pages,
right,
and it's all on this server side, to now things are becoming these web applications, and a lot of stuff, like in some cases all the stuff is happening on the client and the browser, and it's making these API calls, and there's just all kinds of things that are
right. And how do we actually leave it so that it's running, it can be running on the client and you don't need to hit the server, except periodically you do want to check the server to see if there's an update, and how do you update, and lots and lots of, so there's lots of stuff that that HTTP and its related technologies have all evolved into. Yeah. But at its heart, we still have HTTP and its request and response.
Yep. Pretty amazing.
Very amazing how this technology works sometimes and how it's evolved.
Yeah.
So if you've got questions about, how HTTP works, if there's something you feel like we haven't covered or that you want to hear a little bit more about, you can reach out to Mark and I, find us on Twitter, LinkedIn, or in the comments below. And we hope we hear from you, and we will address your questions another time on Two Voice Devs.
Two Voice Devs. Take care, Alan.
Take care, Mark. Have a good week.
All right. Take care, everybody.